Hello dear student, let's continue solving problems from the chapter Mechanics of Solids. In the last video, we have seen how structural elements will respond to bending. In this video, we will see how structural elements respond to twisting. When a structural element, say a rod or a beam, which is clamped on one end and twisted at the another end, it will show some resistance to that twisting, and this resistance is known as torsional rigidity. Therefore, torsional rigidity is the resistance offered by an object to angular deformation or twisting. And here we discuss about two types of angles, that is angle of shear, that is phi, and angle of twist, theta. Angle of twist is the angle made at the bottom of the structural element, and angle of shear is made at the surface. It depends on how much the structural element has undergone a shear deformation. The angle of shear is given by the equation phi is equal to x theta by L, and x is the radial distance of that structure or that concentrical cylinder from its angle of twisting, and L is the length of the structural element. Torsional couple is given by the equation tau is equal to pi n r to the power 4 theta by 2L. We can also find couple per unit twist C given by pi n r to the power 4 divided by 2L. Here n is the rigidity modulus. Also, the structural element, when released from its stress situation, it executes oscillations about its oscillations about its mean position, and this constitutes a torsional pendulum. And this torsion pendulum is a body. When released from torsion, it executes torsional oscillations. And we can find the time period of the torsional oscillation t is equal to 2 pi in root over I by c, where I is the moment of inertia of that object and c is the couple per unit twist. Torsional pendulum is an experiment which can be used to find the rigidity modulus of any material. Let's move on to the problems. First problem. A wire of radius 1 millimeter and length 2 meter is twisted through 90 degrees. Calculate the angle of shear at the surface, at the axis of the wire, and at the point midway where the modulus of rigidity of the material is given as 5 into 10 to the power 10 Newton per meter square. What is the torsional couple? So, this question can be divided into two portions, where in the first portion it is asked to find what is the angle of shear at three different points. So, here we have a rod or a rod which is being twisted to an angle 90 degree. So, this makes two angles theta and phi, angle of twist and angle of shear. So, this is the angle theta and phi. Now, we are asked to find the angle of shear, that is phi, at three different points. One is at the surface. So, we have equation for angle of shear phi. Let's divide it as the first portion of the question. Angle of shear phi is equal to x theta by L. So, let's find the angle of shear at the first portion. We know that theta is always the same, that is 90 degree. First of all, we need to convert this 90 degrees into radian. So, theta is equal to 90 degrees. How can we convert degree into radian? It is 90 into pi by 180. This is how we convert degree into radian. Now, so it is 90 into pi by 180 radian, that is nothing but pi by 2 radian. So 90 degrees is pi by 2 radian and 90 degrees is always a constant, length is always a constant. So what is changing is x at the surface. So at the first point is at the surface. At the surface, x is equal to r. We know that x is the distance from the central point, that is axis, towards the surface we are mentioning. At the surface, it is x is equal to r. Therefore, phi is equal to r theta by L. So let's put values to r, theta and L. We know that radius is given as 1 millimeter. So 1 into 10 to the power negative 3. We have found theta is pi by 2 and the length is given as 2 meter. So when we solve for this, we will get this as pi by 4 into 10 to the power negative 3 radians, or it can be further calculated as 0.045 degrees. So the angle of shear at the surface is 0.045 degrees. Now the second portion, what is it asked to find at the surface and at the axis? Second is at the axis. So at the axis, we know that x is equal to 0. At the axis, x is equal to 0. Therefore, the angle of shear phi, which is equal to x theta by L, will be equal to 0. So there is no shear at the axis. It is 0 degree shear at the axis. The third point is at a point midway. Okay, let's find at the point midway. So this is a point midway. At midway, that is x is equal to r by 2. We know that radius is 1 into 10 to the power negative 3 meter. So r by 2 will be nothing but 0.5 into 10 to the power negative 3 meter. So let's find 5 at this point. It is 0.5 into 10 to the power negative 3. Theta is always the same, and that is pi by 2, and the length is also same, that is 2 meter. So we can find answer for this as pi by 8 into 10 to the power negative 3 radian. We can further solve to find it as 0.0225 degrees. So you can find that angle of shear is maximum at the surface. So phi is maximum at the surface, phi is 0 at the axis, and the phi increases as it moves outwards. The second portion of the question is asking you to find the torsional couple. So we have an equation for torsional couple. Tau is equal to pi n r to the power 4 theta divided by 2l. We have values for all these. Let's find. It is pi 3.14 into eta, that is the rigidity modulus of the material, and it's given as 5 into 10 to the power 10, all in SI unit, that is Newton per meter square. The radius is 1 into 10 to the power negative 3, 1 millimeter, whole to the power 4. Theta is pi by 2, the whole divided by 2 into length of the material is 2 meter. So when we solve this, we will get it as 6.16 into 10 to the power negative 2 Newton meter. And this is the torsional couple of this entire twisting, or the torsional couple experienced by this material when it has undergone a 90-degree twist. Let's move on to the next question. An iron wire of 1 millimeter and length 100 centimeter is twisted through an angle 18 degrees. Find the maximum angle of shear if rigidity modulus of the iron is 8 into 10 to the power negative 10 to the power 10 Newton per meter square. What is the torsional couple? Here also we have two different parts in the question. The first question is one which asked you to find the maximum angle of shear. So phi max is the first portion we need to find. So we know that phi is maximum, that is angle of shear is maximum at the surface. So we are asked to find phi max. So we have the equation for phi, that is x theta by L. When it is phi maximum, we know that x is r. So at the case of phi maximum, r theta by L. So let's substitute. We know that the radius is 1 millimeter. We have to convert 18 degrees into radian. So let's convert 18 degrees into radian. It is 18 into pi by 180. 18 degrees is equal to 18 into pi by 180 radian. So we have converted 18 degrees into radian, and that is something like 0.314 radian. So let's substitute for theta. It is 0.314 radian divided by the length, and that is 100 centimeter. So centimeter have to be converted. It is 10 into power negative 2 meter. So it is 100 centimeter is converted into meter. So it's all set, and we can solve it as 3.14 into 10 to the power negative 4 radian. So this is the maximum shear. 3.14 into 10 to the power negative 4 radian is the maximum shear experienced by that structural element, and this shear is at the surface of that element. The second portion of the question is asking you to find the torsional couple. So the torsional couple tau, we have an equation, and it is pi n r to the power 4 theta divided by 2l. Let's substitute. Pi is 3.14 into n, and that is a modulus of rigidity. It is given as 8 into 10 to the power 10. Radius, it is 1 into 10 to the power negative 3 whole to the power 4. Theta is 0.314 divided by 2 into length is 100 centimeter. So 10 to the power negative 2 meter. And we can solve this as 3.8 into 10 to the power negative 2 Newton meter. And this is the torsional couple experienced by this structural element. Moving on to the next question. Two cylinder A and B of radius R and 2R are soldered coaxially. the free end of A is clamped and the free end of B is twisted to an angle theta. Calculate the twist at the junction, taking the material and length of the cylinders to be same. So, we have two cylinders A and B of same length and same material with varying radius. The radius of cylinder A is r, while the radius of cylinder B is 2r, and they are being soldered coaxially, and the free end of the A is being supported to a clamped to a surface, and the free end of B is twisted to an angle theta. So, when the free end of B is twisted to an angle theta, the junction also twists to some angle theta dash. And we know that the couple or the torsional couple experienced by the two cylinders will be same because they are reacting to the same external couple applied. So, we are asked to find the twist at the junction. What is the twist which is made by the two cylinders at the junction? We are given that the L and N, that is length and material of the cylinders, are same. Since both are reacting to the same external couple, their torsional couple will be equal, that is toe will be equal. So, we need to find the toe for both the different, treat these two cylinders as different at the first point. Find toe for A. Let's find torsional couple for A. We know that A is twisted, the bottom of A is twisted to an angle theta dash only. So, it is torsional couple is pi n r to the power 4, instead of theta it is theta dash divided by 2l. Okay, we know that radius of A is r and the length for the both is same. Now, let us find the torsional couple for the cylinder B. The cylinder B is twisted not from 0 to theta dash, but instead it is being twisted from theta dash to theta, because up to theta the first cylinder has twisted and the further twisting is happened in this cylinder. So, instead of twisting from 0 to theta, it has twisted an angle from theta dash to theta. So, the angle which it is being twisted is nothing but theta minus theta dash. So, the angle of twist of cylinder B is theta minus theta dash. So, let us write the torsional couple. Pi n is same. The radius of the cylinder B is 2r. So, it is 2r to the power 4 and it is twisted to an angle. This is the angle to which it is twisted, theta dash to theta. So, the angle to which is twisted is theta minus theta dash divided by 2 into L. And we know that since it is been reacting to the same external couple, toe of A should be equal to toe of B. So, let us equate these two. Pi n r to the power 4 theta dash divided by 2l is equal to pi n 2r to the power 4 theta minus theta dash divided by 2l, and from this we are asked to find theta dash. So, let us write an equation for theta dash. We are asked to find twist at the junction, and twist at the junction is theta dash. So, we are asked to find theta dash. So, to find theta dash, let us eliminate all the commoners from here. We can eliminate r to the power 4 from the equation. We can eliminate 2l. So the answer here will be theta dash is equal to 2 to the power 4 into theta minus theta dash. So on writing an equation, 2 to the power 4 is 16. So theta dash is equal to 16 theta minus 16 theta dash. So theta dash is nothing but 16 by 17 theta. So theta dash can be found as 16 by 17 theta, and this is the twist at the junction. Next question, what couple must be applied to a wire of 1 meter long and 3 meter diameter to twist one end through 45 degrees while one end is fixed? Rigidity modulus of the wire is given as 5 into 10 to the power 10 Newton per meter square. So what it is being asked? It is a direct question. What is the couple that must be applied so that I can twist a wire to an angle of 45 degree? Its length, its dimensions are given, and its rigidity modulus is given. So it is a direct question. What is the couple that must be applied? So what we are asking to find is the torsional couple, TOR. So we have the equation for torsional couple is pi n r to the power 4 theta by 2l. Now we have theta in degrees, so we need to convert theta, which is 45 degrees, have to convert it into radian. So it is 45 into pi by 180 degrees, and that is pi by 4 radian. And also what we are given is a diameter. We have 3 millimeter diameter. So let's convert it into radius. So radius of this material is 1.5 into 10 to the power negative 3 meter. So let's substitute to the equation. It is pi 3.14 into rigidity modulus is 5 into 10 to the power 10, and it's given. We have found the radius to be 1.5 into 10 to the power negative 3 meter. So whole to the power 4, and theta is pi by 4. So 3.14 divided by 4, and the whole answer divided by 2 into length is given as 1 meter. So let's solve this equation, and on solving we will get answer as 0.312 Newton meter. So this is the couple that must be applied to the wire. We know that the torsional couple is same as the external couple that must be applied. So when a question asks you to find what is the external couple that must be applied to twist a wire to certain degrees, what you are actually asked to find is the torsional couple, because both have to be same. The external couple have to be same to the resistance which is being developing inside. So the external couple that must be applied is equal to torsional couple which is being developed inside. So we can just calculate torsional couple and find the external couple. Next question, a wire of length 1 meter and diameter 10 to the power negative 3 meter fixed at one end and is twisted through 70 degrees by a force of 5 into 10 to the power 3 kilogram weight. Keep an eye on here, we will come to that. applied to each end of 0.2 meter length rod soldered at the middle point to the other end of the wire. Calculate the rigidity modulus of the material of the wire. So, we are asked to find the rigidity modulus, and the scenario given is twisting. We have given enough information to find torsional couple toe. So, torsional couple toe can be calculated, and we have equation for torsional couple, and in that equation we have eta, that is the rigidity modulus. So, on rearranging we can find the rigidity modulus also. So, the question here is, what is the torsional couple toe? So, torsional couple toe is also equal to the external couple applied. External applied couple. So, in this element, which is the material which is being undergone twisting, this wire, the wire here is which is being undergoing twisting, and it is twisted by giving equal and opposite force to this rod. So, the torsion, the couple experienced by this wire is nothing but force into distance. So, how do we find couple? It is force into distance. So, the external couple is equal to force into distance. Now, we know that force in SI unit is in Newton, but here it is given that force is in kilogram weight, not in Newton. So, we need to convert kilogram weight into Newton. So, to convert kilogram weight into Newton, just multiply it by 9.8, that is acceleration due to gravity. Therefore, force here given is 5 into 10 to the power negative 3 kilogram weight have to be converted to Newton first, and that is done by multiplying it by G, that is 9.8, and this is the force in Newton multiplied by the distance between these two equal and opposite force, and that is nothing but the length of this rod, and the length of the rod is given to be 0.2 meter. So, we can find the external couple as 9.8 into 10 to the power negative 3 Newton meter, and this external couple is equal to the internal couple or the torsion of the material. So, we can find, we have the torsional couple of the material toe. We have find torsional couple. We have equation for torsional couple toe, which is given by pi n r to the power 4 theta by 2L. From this equation, we can write an equation for rigidity modulus eta, that is 2L toe divided by pi r to the power 4 into theta. Again, here theta is given by 70 degrees. So, we need to convert this 70 degrees into radian, and 70 degrees into radian is nothing but 70 into pi by 180 radian. So, we have enough values. Let's substitute these 2 into length of the material which is being twisted, that is this material, the length of the wire, and the length of the wire is given as 1 meter. We have found toe as 9.8 into 10 to the power negative 3. We have pi. Now, r to the power 4, which are the radius of the material which is being twisted, and the diameter is given as 10 to the power negative 3 meter. which implies that the radius is 0.5 into 10 to the power negative 3 meter. Okay. If it is 1 into 10 to the power negative 3, if the diameter is 1 into 10 to the power negative 3 meter, radius is 0.5 into 10 to the power negative 3 meter. So, radius is 0.5 into 10 to the power negative 3, the whole to the power 4, and theta is 70 into pi by 180. So, let us solve for all these, and on solving we will get it as 8.798 into 10 to the power 10 Newton per meter square. So, rigidity modulus of this material of the wire is 8.798 into 10 to the power 10 Newton per meter square. Let's move on to the last question. A metal disc of diameter 1 meter and mass 1.2 kilogram is fixed symmetrically to the lower end of a torsion wire of length 1 meter and diameter 1.44 into 10 to the power negative 3 meter. The upper end of which is fixed. The time period of torsional oscillation is 1.98 seconds. Calculate the rigidity modulus of material of the wire. So, we have given enough information about the torsional oscillation executed by this torsion pendulum. So, the material under torsion is this wire, and this disc is used to give the external couple, and also this disc execute the torsional oscillation. By looking into how this disc execute torsional oscillation, we can find the material of the wire. So, we have equation for the time period of torsional oscillation, that is T is equal to 2 pi into root over I by C. Here I is the moment of inertia. So, moment of inertia, and C is the couple per unit twist. Now, what we have given here is a disc. So, moment of inertia of a disc is given by mr square by 2. We have seen this in our previous chapter, dynamics of rigid bodies. That is, I of a disc is mr square by 4, where m is a mass of the disc and r is the radius of the disc. And also we have equation for couple per unit twist, that is pi n r to the power 4 divided by 2l. And we have given information about T also. So, what we are asked to find is the rigidity modulus of the wire. So, eta is what we are asked to find. So, let's equate put these two equations into the equation for T. Before that, I would like to square the equation T, because C comes inside the square root. So, to make it simple, I am squaring this equation number 1. So, on squaring, it is T squared is equal to 4 pi squared I by C. This is just to remove the square root. So, from this, let's write the equations. From this, C can be written as 4 pi square into I by T squared. So, let's substitute for C and I. C is pi n r to the power 4 divided by 2l is equal to 4 pi squared into I. I is m r squared by 2 into 1 by T squared. From this equation, let's write an equation for eta. Eta can be written as 8 pi by r to the power 4 into m r squared by 2 into L by T squared. We have L here, so it is L by T squared. On substituting for all these values, we have a mass of the disc that is given as 1.2 kilograms. We have radius of the disc, and we have diameter of the disc, which is given to be 1.1 meter. So let's convert it into, we have diameter of the disc which is given to be 0.1 meter. So divide it into 2, that is 0.05 meter is the radius of the disc, and let's substitute all the values. 8 into pi into mass is given as 1.2 kilograms, radius is 0.05 meter to the square into length of the wire. This is the length, and the length of the wire is given as 1 meter. Length is given as 1 meter. Now radius of the material, again we are given with a diameter, so let's divide it into 2. So the radius of the material is 1.44 divided by 2, that is 0.72. So it is 0.72 into 10 to the power negative 3. It is the radius of the material. So r to the power 4 into 2 into time period the square, 1.98 square. So on solving this equation, we will get rigidity modulus of the material to be 3.579 into 10 to the power 10 Newton per meter square. This is the rigidity modulus of the material wire. Thank you for watching.